Hey, welcome to a video in which we will demonstrate how to use the mesh combiner feature. So this has been done, this feature for the game anti-air. So the CombineMeshes functionality on a mesh in Unity allows you to gain performance benefits. Combine several meshes into this mesh, into a single mesh. Combining meshes is useful for performance optimization. And so this is one of the important things for the game. And in the game you have different enemies. We call them cubicons. And these cubicons, you can shoot them apart in smaller pieces. And this CombineMeshes method gave us the performance we wished for. So we will look into two different kinds of CombineMeshes usage. One is the single material. So we will have one material for all the blocks and parts inside this cubicon. And we have a cubicon with multiple materials. And so this is a white material that is used for all the shapes. And here we have a yellow and a red material used for all the shapes. So I've already set up the scene. And if we run the scene, it will combine these different meshes that are inside the root object into one single mesh. So as you can see here, that it currently has no mesh in the mesh filter and it has no material. And this will be generated, this one as well, and it is also set here in the variable we've added. So for this scene, we have a normal Unity scene, and we have three custom materials, red, white, and yellow, and we have a CombineMesh script. And this script will be shared in the links of the video. And the thing is, this script, you can just drag and drop it onto an object, populate the object with all kinds of shapes, and you can configure the script and it will do the work for you. And of course you can adjust it, customize it any way you like. So let's see it in work. So we have this object with multiple objects inside of it, and it will generate one mesh out of it. So, and this is it. And we have these two meshes now. You see it has also removed the objects it used. And now we can see that the mesh filter component in the object has data that has the mesh. So if we click it, we can see that the mesh has been generated. So this is nice. And it's the same for the other one. Here we go. Okay. So one other option is the mesh collider. For this one we didn't use it. For the other one we did, for the multiple materials one. And what you see it has done, it has add a mesh collider, and it uses the mesh object again as its collider shape. So that's how you can add it to your collision your physics system. And so that's another option you can turn on or off. Okay, if we stop the editor from playing, you can see these objects are back. So only during runtime it will generate this optimized object, and then we can have these performance benefits, but in the editor we can still customize this shape. For example, if we don't want this object, and let's edit it a little bit. Add it to the middle. We do something like this. So if we would like this to be the object, we can run it again. And as you can see, it will generate this new object. And which is consistent of all the different objects that were inside as child objects in the bigger object, the root object, as the new shape. And so this is our object, and it's the same for this object. For example, if you would like to change some of the materials as well, let's do it like this. And we have our different materials and different objects inside the root object. And as you can see now, the object is slightly different, but also the materials are on different elements. So that's the CombineMeshes functionality. So pretty useful to optimize your meshes. Now let's take a look at the script. So we have the script. So what you would like to do is you would like to assign a static root. Well, let's create a new sketch, and I'll just copy paste my cube. And where is it located? Here it is. And what I'm gonna do is I'm gonna create a sample shape. Let's place this one over here. Okay. So we have our shape. Let's add some materials to it. Something like this. And pretty random. And now let's add our CombineMeshes component to it, or script as component. And we would like the mesh filter and the mesh renderer. And we just add these empty. The combine mesh script will fill them up. But of course you can tweak these settings to your liking. So for static root, we would like to select the root object in which the optimized mesh will be set. We have 3 materials, so we will be using multiple materials, so we will skip the shared material single. There is more optimization benefits here. So if you can have your material consist out of your object out of a single material, and use only the single material. But I selected 3 of them, and what I will do is I will randomly add the 3 materials to this list. And let's choose to also use the mesh collider, so we'll also add the mesh collider. If you choose not to use it, you don't have to add this component. And we set it to on, because on will make sure the script will run. If you turn it off, it will not run the script, it will not optimize the object. So this is how you configure the object. Now let's run it. And as you can see, here we go, we have our mesh. It has the 3 materials. We use multiple materials. And so let's change it to using a single material. I'll just show you the difference. And well, let's keep the mesh collider. Let's run it. And as you can see, we have our mesh, but it just uses a single material. Note, if you spawn multiple of these kind of objects, it is wise to enable GPU instancing on your mesh. Since if you have many objects, it will use the GPU instancing performance addition, which is huge, to your scene as well, to your objects that use the same material as well. So make sure to turn your GPU instancing on your material on. And by default, I think it's off. Okay, so that was the working from the Unity editor. So let's look into the CombineMesh script itself. So here we go. And so it's used in there, the Cubicon conjunction. And here are some extra references to the Unity website reference guide, where you can read more about meshes, filters, the CombineInstance, and the CombineMeshes. And so these two specific are used in this class to have the optimization benefits. Well, here you can see the parameters that could be set inside the editor with a description. So the static root, the root object, the shared material single reference, whether you would like to use multiple materials or not, the shared material multiple list where you will add the materials, and the, whether to use the collider or not, and if it's on or off. So in Awake, it will see if it has a static root. If it has no static root, it will use the default transform GameObject as root, and to which it is attached. Then it will check if it's on and if it has a static root. If so, it will initiate the CombineMeshes, and it passes forward the shared material single and shared material multiple reference. Since you're in the same class, you don't have to do that. It's not mandatory. You can access them in the initiate combine mesh as well. This is due to some optimization for the script to make it available, and I didn't remove that. But you can adjust this to your liking. More about that you've seen an example of how it is used, the mesh combine feature. So after we have combined the mesh, which we will go into shortly, after that process, it will remove all the child game objects. And so that's why you, in the Unity editor, when we run the game, all these objects are gone, and because we remove them in the code here. And finally, if we would like to have a mesh collider, it will add the mesh regenerated to the mesh collider. So that's the final step in this awake method. So let's look into initiate combine meshes. So we have either we use multiple materials or we use a single material. So let's start with the single material. With the single material, we have the this method. It will call the combine mesh to one part, one material. And in one part, one material, we can see that it goes through 3-4 steps. So the material or the method, it requires an object, a game object, and it requires a material. So first we store the position and the rotation of the object. We will move our object to the center of the Unity scene, which is the 0 location, 0 for X, Y, and Z. And we use the identity quaternion for its rotation. And in the end, we will rotate it back, the whole object. But for matrix calculations inside the mesh combiner, this will create less conflicts. But you can also adjust the matrix calculations. So step 1 is to collect all the mesh filters inside all the child objects of the static root, the object with meshes. And the second step is to create a list of combine instances. And to these combine instances, we will add all the mesh filters. And so we have this list of combine instances generated, which contains all the meshes and their positions. And then we will generate a new mesh. And on this mesh, we will call CombineMeshes. And what we pass along is the instances list. So the mesh combine instances list we generated in step 2. And here we have the performance, the extra performance benefit from Unity, which works with when you only use a single material, and that is the mergeSubMeshes. So it will merge the submeshes. And so this is the Unity performance benefit which you have with a single material. And you can set this to true. And lastly, we will position and orient it back to its original position we had it in the scene itself. So that's all there is to it if you use a single material. And so that's for this single material situation. But we also have the multiple material situation, and let's dive into that one. So that's this method. If we use multiple materials, it will pass along the static root and the multiple material list. And it will pass it along to combine meshes based on multiple materials. So here we go. Combine meshes based on multiple materials. In are the root, the static root object, which contains all the children, and the object's material list. Next is we again position the object at the 0 position of the world. Step 1 is collect all the mesh filters of all the children inside the static root. We prepare 2 lists, one for the submeshes, one for the used materials. Since we use multiple materials, we want to collect 1 reference of each of them. Step number 2, step through the materials used on the object. These were set manually in the list shared materials multiple. So we will search for all the child objects that use either in this case the red or the yellow material. So for the red and the yellow material, we're going to look for children that match that material. So that's step number 3. Next, create a list of combined instances and steps for each mesh filter to match it on material type. And then we will add them to a list of combined instances. And we also store the unique materials while we're doing this. Okay. So if you would add more materials here than are actually used in the objects, it will optimize this list to only the used ones. So that could be in certain cases relevant. So we have the combiners list, and we have this mesh filter list. So all the children mesh filters. So let's step through them. Let's take the renderer of each child and see what materials are on it, and if the materials is of the material we're looking for. This in the first case we are looking for red, and we do this twice, this for each loop, one for red material, one for yellow material. And if a child matches the material type, it now knows that the material is used, and it will add this mesh and the mesh of the child to a combine instance. And it will add this combine instance to the combiner instance list. So we have collected all the red mesh filters, and what we will do with it, we will turn it into a single mesh. So all these red parts will become one mesh, just as we have done with one single material for the single material. This mesh we will add to submeshes, and the next time we iterate through the for each loop for the materials, we will collect all the yellow objects with using the yellow material and also add them to a submesh, to a mesh, and add that mesh to the submeshes list. So this way we have different submeshes, different meshes for each used material. But now we would like to put that all together. We don't want the separate meshes, we want just one mesh. So that's the step number 5. Step through all the submeshes and generate that were based on the materials in the previous steps, and combine them into a single mesh. So we have here our submeshes, the red and the yellow are inside of it in this example, and it will add these meshes to a combine instance. So we have 2 combine instances for the red and the yellow in this combiner's final, and from this final combine instances list we will generate the final mesh. So use the combine instance from step number 5, combine them into the final mesh, and set the unique use materials. In this case, the red and the yellow that were found when iterating through all the children. So the red and the yellow mesh and the red and the yellow material will be set here to the final mesh, a final mesh. And again, we call CombineMeshes on the final combiners list. So on these 2 meshes that are inside of this, and actually the combine instances based on the meshes that are inside of this. And we will set the shared material, and we will the shared mesh and the shared material. And you can see here that where in the single mesh, a single material version, the merge submeshes was set to true. We cannot do this here. Here we have to set it to false because we use multiple materials. And the Unity guide, let's see, if merge submesh is true, all the meshes are combined to get into a single submesh. Otherwise, each mesh is placed in a different submesh. If all meshes share the same material, this property should be set to true. But we have different materials, so we cannot set it to true. So that's a big change, a big difference. And finally, we have our mesh. The mesh is set to the what we do here is that we set the mesh to the mesh filter and the mesh renderer. So let's collect them. Here we have the mesh filter, and here we have the mesh renderer. So that's where it assigns it to. And last we position it back to its original position it was in the world. And we just have a debug message, and it tells us how many submeshes were counted. Okay, so this is the script. You can find it in the link below the video. And that's it. Let's see it in action one more time. So we have our parent objects with all kinds of different child objects, and when we run the game, it's optimized into a single mesh with the minimum amount of materials used. The more optimized. Also, don't forget to turn on the enable GPU instancing. And that's it for this video. If you like the video, leave a comment. or anything. And for questions, also feel free to reach out. Hope you enjoyed it, and good luck with all of your games. See ya!